Hello, I am Jimmy Hu from Peking University. The topic of my presentation is eye fixation forecasting in task-oriented virtual reality. Let's start with the background of this work. Human visual attention is a popular research topic in the area of vision research and is significant for many relevant areas. Human visual attention can be applied to marketing strategy analysis, cognitive research, medical education, gaze-based interaction, collaborative system, gaze-contingent eyeglasses, and so on. In the area of virtual reality, human visual attention can be applied to gaze-contingent rendering, redirected working, layout optimization, web content design, gaze guidance, as well as LOD management. The research goals of this work are twofold: analyze and reveal the characteristics of users' task-oriented visual attention in VR, forecast eye fixations based on the characteristics of visual attention. Our research is related to the work of ceiling object detection in the area of computer vision, which aims at predicting ceiling objects from images. Another important related work is ceiling prediction. It predicts ceiling maps from the input images. Recently, researchers have focused on gaze prediction in static free-viewing virtual environments, as well as gaze prediction in dynamic free-viewing virtual environments. Compared with previous work, we predict eye fixations rather than ceiling objects or ceiling maps. We focus on immersive virtual environments and task-oriented situations instead of images, videos, or free viewing conditions. In our current research, we propose a novel learning-based fixation prediction model called FixationNet. We analyze and reveal the characteristics of users' task-oriented visual attention in VR. We build a task-oriented VR eye tracking dataset. In the data collection process, 27 users were asked to perform a visual search task in 4 immersive virtual environments. Each environment contains 3 types of objects, and users were required to search for a particular type of object. We utilized HTC Vive and Eye Tracker to collect the data. We recorded the VR content, the task-related objects, eye fixations, and users' head movements for further analysis. This video shows our experiment environment and the data collection process. Users could cast a ray using the controller to hit the object and continue to search for the next target. We analyzed the correlations between users' eye fixations and their historic gaze positions. The results indicate eye fixations are highly correlated with historical gaze positions. The correlations between eye fixations and task-related objects were also analyzed. The results indicate that fixations are correlated with task-related objects. We further computed the distribution of users' fixation positions on the ceiling regions of the VR content. The result shows that the fixation positions are mostly located in the regions with high salience values. We also revealed that eye fixations have correlations with the users' head velocities. This is the architecture of our model. A fixation net consists of a feature extraction network and a fixation prediction network. The feature extraction network utilizes SMResNet to extract features from VR images and utilizes 1D layers to extract features from task-related data, gaze data, and head data. The fixation prediction network combines the extracted features and the cluster centers of the eye fixations to forecast users' eye fixations in the near future. The prediction performance of our model and other methods are illustrated in this figure. The y-axis indicates a prediction error. The green bars indicate the results of our method. We can say that our model outperforms other methods at different prediction times. I have some key questions to discuss here. In our current research, we only focus on a visual search task and immersive virtual environments. There is still plenty of room to improve our work. First, human eye fixations may also have correlations with other factors such as sound, users' mental states, users' gestures, and users' behavioral habits. Second, exploring users' gaze behaviors in other tasks such as task editing tasks, assembly tasks, collaborative tasks is an interesting avenue for future work. Third, it will be very interesting to apply our model to intelligent user interfaces and relevant areas. Finally, we can apply our model to other systems such as AR, MR, and mobile VR systems. This is the end of my presentation. Thank you for your attention.